do you think it is?
What do I think it is? Is
Yeah,
it going
which
up? It's going up again, isn't it?
it's going up. Yes, it's going up, but again, which one? Linear, quadratic, or exponential?
It's not linear because linear goes. Isn't linear only going down
No,
most of the time?
linear could go up like that, or it could go down too. It could go down too. Linear just means straight line. A
Oh
straight
yeah,
line
yeah,
go up, a
yeah,
straight
yeah.
line could
It's
go
just a
down.
straight. Yeah, I just seen it.
Okay.
I think is this a quad no exponential?
Why would it be exponential?
It's going up. It's going up.
But all three can go up though.
Huh?
All three cases, linear, quadratic, and exponential, can all go up.
It has growth though. No,
How
no,
much growth? Right. How much growth? Is it crazy growth?
not crazy growth, but it's going up still though.
It's crazy growth. No. Number three is crazy growth.
Okay.
Okay, so it starts off the Y start
Yeah,
off at one and they
it
end up
winds.
at 81.
Okay, yeah, yeah, it does, it does. Number four
Right.
doesn't have crazy.
Okay, so what would number four be?
Number four, the biggest number is 19, and it doesn't have any growth for because it's like it's declining and then it's it's going up, but then it's coming back down, but going back up, if that makes sense.
Okay,
So
so
like
just make a
it,
rough sketch of what you think it looks like. So something like that.
so like it's starting up, going down, and then coming right back up again.
So which one are the three?
Um, let me see.
Look at my diagrams on the right. Look at
It's,
the pictures I'm drawing.
I think it's X. No, you said the it's quadratic.
Yes. Okay, number four is quadratic. Number five. Tell me why. Tell me which one and why.
Let me see. Let me see. Let me see. This one is is what's the naming? What do you call it? Decline. How do you pronounce it again? Declining.
Which
It's
one?
going down.
Yes,
Number
it's getting
five.
yes, it's getting smaller, right? A little bit smaller
Yeah.
each time.
Yeah.
So which one? A little bit smaller each time. Which one could that be?
A little bit smaller each spawn.
So see, look at the diagrams I'm drawing on the right.
Yeah.
Okay, so which one do you think of the? Those are pictures of the three cases. Which
And this one
case?
also quad
No, this one would be linear.
linear, but
Linear.
it's going down at a slow.
Exactly. It's going down very slowly.
Okay, so if it's going down very slowly, then therefore it's linear.
Yeah. Yep.
And then if it's okay. Oh, let me see. Number six. Number six is inclining.
Number six. Okay, so what's going on with number six? 8,
And
12,
it's
16.
inclining. It's inclining by fours.
Okay, so which one is it? Which one?
It's inclining. It's inclining.
It's increasing by four. The y is are increasing by four each time. Yep.
Yeah.
So this one will be linear because there's a constant difference between the numbers.
Okay. Okay, that makes sense. Okay.
That one would be linear. Okay, so there's your answers: exponential, quad, linear, linear.
Okay.
So see those pictures on the right. Just imagine those pictures. Which one do those inputs and outputs look like most?
Okay. I get it. So say something's inclining or declining at a constant rate, then therefore it's just automatically linear.
Linear, yep, linear.
Okay, and then if something is going up like at a high rate, it's quad.
If it's going up high at a very high rate, exponential.
exponential.
If
And
it's
then
going
what?
if it's going up but not crazy, then it's
Quad.
quadratic.
Okay. Okay. I'm gonna write that down really quickly. If it's quadratic, it's how do you know if it's quadratic again? Sorry.
If it's increasing, but it's not increasing crazy. It's still like symmetric. You know what symmetric means? It's symmetric. It's either a U shape. It's a U shape that opens up, or a U shape that opens down,
Okay.
or part of a U shape that opens up and part of a U shape that opens down. It's increasing, but it's not increasing like exponential. But it's increasing more than linear.
Okay. I got it.
All right, you got some other stuff you want to review?
Let's see. She's gonna be giving us the quiz back, the quiz that I didn't do too good on. When she gives it back, uh, I want to see if I go over it with you.
Okay, and when did she give it back?
Tomorrow, I think. And then, but she's not gonna be here for the rest of the week. So I'm gonna have something else to do. Like
Okay, so
over.
all right, you say you want to go over these other questions? 7, 8, 9?
Yeah, I might as well just do it now, so get it over with, be ahead.
Okay. All right, you tell me. You read it and you tell me.
The data in the table represents the population of the town, the past of the town for the past 5 years. When the population reaches 100,000, the town can be reclassified as a city. Does this situation suggest a linear, exponential, or quadratic function model? Would the town be reclassified as a city in the next 8 years?
Okay, so look at the numbers on the right. See this chart right here? Okay, so what can you tell me about the chart?
Um, Let me see. It's kind of inclining. Well, not kind of, but it is inclining.
Okay.
It's inclining, isn't it?
It's inclining, yes. 85, 85, 86, 88, 81. It's inclining, but it's not inclining crazy, right?
Yeah, it's taking
Inclining
its
a little
time.
bit.
It's going like a quadratic. Yeah, quadratic, right? Like it's moving at like a quadratic. Because
Not just quite,
you said it is
yeah.
quadratic doesn't go at a fast pace, and this one isn't going at a fast pace really. It's
Yeah,
going. It's
okay.
going. Wait. It would be a linear, not quadratic, wouldn't it?
Linear. Yeah, I think quadratic. I think this one will be quadratic
Quadratic.
because
Okay.
kind of like what you said. You said it was okay. So here are the reasons, right? One, it's increasing. I'm just going to draw an arrow that's going up. So that's one reason. Another reason is maybe it's not increasing. It's not increasing a lot, like very fast, and it's not linear because linear would be more something like 85, 86, 87, 88. That would be
Yeah,
more linear.
because then it's moving at a constant like
Yes.
up number each time. Okay.
So that's why I'm saying quadratic because it's not linear like we just discussed, and it's not
Okay.
crazy exponential growth.
Okay.
So quadratic. Okay, so now look at the other questions they ask you.
Consider linear, quadratic, or exponential functions.
So which one there?
What
Now we're okay. So we're
what
saying
type of
quadratic, right?
yes? What type of function would best model the area of a figure? Do I write quadratic right there?
Okay, hold on. We're not done. We're not done 7 yet. We're not done 7.
Oh, I thought they were all okay.
We only answered the first question in 7. So look at the second question. Will the town be reclassified as a city in the next 8 years? So look, they're getting you trying to ask you what 6, 7, and 8 are. So what do you think 6 would be? What do you think 7 would be? What do you think 8 would be?
Hold on, let me see. Hold on. Hmm. Hold on.
So it's
So
increasing. It's increasing, but it's not increasing a lot very fast. So what do you number do you think this would be here?
100,000.
At 6, 7, or 8?
6.
You think this would be 100 here?
Does number 8 have to be 100,000?
It doesn't have to be, but you just have to like come up with a reason whether you think it is or not. That's what they're asking you.
Okay.
So just to estimate, I mean, there's no perfect answer on this. Just to estimate, if year 5 it's 91,000, year 6 would be like maybe like 92 or 93,000. Same thing with the next year. Add 2 or 3. This would probably be 95 maybe.
94. I could do 94 right there. No, no, yeah, 95.
And then maybe 97 or maybe even 100 here.
So you're gonna jump from 95 to 100,000?
It's possible. I mean, it's possible, right? Yeah, I'd say it's
Could
possible.
couldn't I just, instead of going up one, put 693, 790, and then 796,
Yes. Yep.
and then 800.
Yeah. So what's the answer to the question they're asking? Yeah, you could. What you said. Yeah, that makes sense. What's the answer to the question they're asking?
I'll be going up three the first two numbers, and then going up 4. But
Okay.
what were we saying? Sorry.
Look at the last question. Will the town be reclassified as a city in the next 8 years? Yes or no, and why? Based off the numbers you just told me.
Yes, it will.
Okay, so then just justify your reason.
The town will be classified as a city in the next 8 years because each for real, sorry, each year it's going up. Each year the population has grown 3 or I don't know how to explain it, but each year the population has grown another. I don't know how to say it.
How do you know it's a city though? What classifies that town as a city? What would classify that town as a city?
When the population reaches 100,000, the
Okay,
town will be classified as a city. And with the numbers that I used and said, the population has reached 100,000.
there you go. That's your justification. Yes, because the population reached 100,000.
So, so you want me to say that?
Yeah, just make it short. Will the town be reclassified as a city in the next 8 years? Yes, because the population reached 100,000. That makes sense, doesn't it? All you have to do is just answer the questions they're asking. You know what I mean?
Okay.
Just be concise. Just look at the question they're asking and be concise. Yes or no, and why.
I'm writing it. Sorry.
All right.
Okay, I got it.
Okay, 8. Tell me what you think.
Is that it?
Is what it So
Huh?
we're on number 8. Read number 8.
Yeah. Consider linear, quadratic, or exponential functions. Exponential. What type of function would best model the arena of a figure?
Area of a figure.
Huh?
Area of a figure.
Area of the figure.
So which one?
Isn't that basically us just saying how he said it's quadratic?
What type of function would best model the area of a figure?
The quadratic function, right?
Well, tell me why.
Wait, is it before we said anything, we said that it was quadratic, but just now me adding the numbers, does that mean that it's not quadratic anymore? Because I feel like it's not quadratic anymore. Because wait, yeah, I think it still is. I think it's a quadratic because it's still moving up at a calm speed, like it's not moving up pretty fast. Because I'm just moving up 3, 3, 4. I don't think that's pretty fast, is it?
Well, it's all relative, right? It's all relative to something else. If the something else is moving fast, then no. You know what I mean?
Yeah.
Okay, so we're on question 8. Consider linear, quadratic, and exponential functions. What type of function would best model the area of a figure? That doesn't even make sense. But to answer their question, I think what they're trying to ask is, you said quadratic, and what was the reason you said quadratic again?
Huh?
You say quadratic. Why? Why?
Because like it's not moving up at a fast speed. Because I'm literally only moving up 3, 3, and then 4. That's literally just moving at like a calm speed.
Are you talking about the chart in number 7?
Isn't that what we're using?
No, that's only for 7. 8 is a different question.
Consider linear, quadratic, or exponential function. What type of function best model the area of a figure? Okay, okay. Sorry.
Yeah, leave that chart out for just ignore that chart. That's only for 7.
Okay.
But for 8A and 8B, those questions don't make sense. I don't know, these people they write these textbooks, they don't really
I could
understand.
I could ask her about it tomorrow.
But okay, let's skip 8 for now. What you have to do 9. 9 also?
Yeah, because
Okay.
8 was supposed to be for another day anyway.
Okay.
So it
All
doesn't.
right. Well, we'll come back to 8. We'll come back to 8. All right, let's look at 9. Okay, so they say f of x is 2x plus 4, okay? And okay, so all that means is one function. The other function, g of x, is 2x squared plus 4.
Mhm.
Okay, so the only difference is they square the x on the second one. Okay, so oh no, there's a third one. H of x. H of x is 2 to the x. Okay, so we have 3 functions. Which function has the greatest average rate of change? What does that mean?
Like it's moving average rate of change.
Yeah, what does that mean? Which function has the greatest average rate of change? So basically, which of the 3 ball players is moving the fastest? Which which
Is it
receiver is moving the fastest? Which
is
running
it
back
is
is
it
moving the fastest?
is it G?
Tell me why. Whatever you pick, I'm gonna ask you why. Tell me why. Why you say G? Are you with me?
Yeah, I just don't know.
I mean, look at the functions though. Like, look at these functions. Okay, so which one's moving the fastest? Just by looking at it, just by guessing, which one of the 3 you think is moving the fastest? Just look at the function. Look at the equation.
I would say it's G.
You'd say this is first. Okay, which one would be the second fastest? Which one would be the slowest?
F.
1, 2, 3, like that.
Yeah.
So you're saying h of x would be the slowest?
That's what I'm guessing.
Okay, and g of x would be the fastest. Is that what you're saying?
Yeah.
Okay. Okay. So it's really like you get the general idea of what I'm trying to say, though, right?
Yeah.
Okay, so here's the real order. Here's the real order. This would be the fastest. This would be the second fastest. This would be the slowest. How do I know that? Why do I say that? See, look at h of x. H of x, you're taking the number 2 and you're plugging in an exponent. That's exponential right there. See what I'm saying?
Yeah.
This right here, the power x, the exponent x, that's your exponential. You already know exponentials go moving the fastest. So that's why I'm saying the third one will be first. The one with the power of 2, the one that you thought would be the fastest, is the second fastest. And then the one on top, 2x plus 4, that would be the slowest. That one would be linear. So basically, this one is linear. This one is linear. This one is quadratic. And the last one is exponential. Okay, so we know exponential is the fastest. That would be number 1. Quadratic would be number 2. Linear would be the slowest. So look at the question. Which function has the greatest average rate of change? All that means is which is the fastest, which is the slowest.
H. H is the fastest.
Yes.
That what I'm supposed to write?
Which function has the greatest average rate of change? H of x. H bracket, x bracket. Make sense?
Yeah.
It's really like just simplify it, man. Don't like think too much about it. Just look at it and do your thing. Okay, all right, let's go. Oh, let's finish 8. Let's go back to 8. Okay, this is a bad question they're asking, but what I think they're trying to ask is okay, you know what area means, right? Area is just length times width, right?
Uh-huh.
So area is just length times width. Length times width. This would be your L, this would be your W, right? But what's perimeter? And then look at the second one. Look at part B. What type of function would best model the perimeter of a figure? So perimeter is the same thing as 2 length plus 2W. Okay. Okay, so what's A? Tell me why. What's B? Tell me why. Area. Think about 2 numbers that you're multiplying. Which one of the 3 would that be? Linear, quadratic, or exponential?
I don't get it.
Okay, what's area? How many dimensions? Two dimensions, length, width. Are with me?
Yeah.
Okay, so you're just multiplying 2 numbers. When you multiply 2 numbers, it's to the power of 2. So which one of the 3 is that? Quadratic. Why? Because it's 2 dimension. Quadratic because it's 2 dimension. Do you know what that means?
No.
You know what 3 dimension means?
You said free dimension?
3. 1, 2,
No.
3. 3 dimensions.
She hasn't said anything about that.
But I'm just asking you in general.
No.
You don't know what 3 dimensions means? It's okay. You just don't know what it means?
No.
Okay. Then I won't ask you what two dimension means. Okay. But get back to 8A, it's quadratic because it's two-dimensional. Two-dimensional. All right, so that's the answer on 8A. Let me erase this. Okay, so what's part B? How many dimensions?
What type of model would best fit the perimeter of the figure?
Yes.
They're asking me to make a model.
No, they're just asking you which one of the three. Linear, quadratic, or exponential. So see what I wrote over here? Perimeter equals 2 length plus 2 width. On the bottom left. So you're just adding two numbers. When you add two numbers, is it linear, quadratic, or exponential?
When I add two numbers,
When you add two numbers together, is it linear, quadratic, or exponential?
exponential, it's going up. I'm add two numbers. I think it's exponential. That's my guess.
Okay. It would be, but remember what exponential is. They're all three cases are could be increasing or could be going up. It's just a matter of how fast they're going up.
Yeah, you said I add two numbers, right?
Yes. So it's linear because it's going up. It's not going up crazy. It's not going up like quadratic, but it's going up slowly. All right. So for the answer for that one would be for AB it would be linear because what? Because you add two numbers together because it's one dimensional. Linear because it's one dimensional. Because it's one dimensional. You're just adding two numbers in one dimension. You get it?
Yeah.
You have one dimensional, two dimensional, three dimensional.
Uh-huh.
So know the difference.
I'm gonna ask her more about the dimensional.
Well, just think about it. Just think about it in general. One dimension is one length. Two dimensions, length, width. Three dimensions, length, width, height. There's your three dimensions. Get it? Length, width, and height. Those are your three dimensions. L, W, and H. Okay? Three dimensions. Something like three dimensional. A basketball, three-dimensional. A football, three-dimensional. A laptop is three-dimensional. 3D, three-dimensional. All right. Okay, so we did 7, 8, 9. Okay, so let me write on the screen for you that last one. We talked about 9, right? H of x because it's exponential. Number 9 is h of x because it's exponential. Because it's exponential. So what's the difference between the three of them?
The difference?
Yeah, the difference.
Other than they all have different stuff going on, like different functions other than that.
Like just know the difference, know the characteristics of each of the three. And in mathematical terms, know what the formulas look like. One dimension is power of 1, two dimension is power of 2, exponential is power of something crazy high. Some big number. Okay, so that's the difference. They're all could be increasing. It's just a matter of which ones. It's just a matter of how fast they're increasing.
Uh,
Okay. Are you got some other stuff you want to go over?
it's pretty much all she gave us for today.
All right. What are you guys working on tomorrow?
I'm pretty sure she's gonna give us more notes and more problems. It's pretty much it.
Okay. You don't have that stuff with you already?
No, she gives us new stuff every day.
She gives you handouts every time?
Huh? Yeah, like she gives us a new packet every day. We just go over it in class, and then we